Okay, let's now have a look at layer 2 circuits, how we can actually use MPLS to transport layer 2 traffic for point-to-point connections. We are gonna first of all introduce how, in a way, signaling works for layer 2 circuits and how forwarding is actually done. Then we will have a look at the configuration, which is very simple. We will check how to troubleshoot layer 2 circuits, what output can you expect from a Juniper router. Finally, we will check auto discovery and how to configure it. This is especially important, not so much for layer 2 circuit, but it's going to be very important later on for VPLS. So, first of all, this is a standard technology, so I can interoperate with other vendors. It's defined in RFC 4447. It uses LDP for signaling, and you don't have BGP, and in its basic exceptions, you don't have routine instances. You just build pseudo wires and you assign to each of them a different circuit ID, and you then exchange labels. For transport, you can use RSVP or LDP, it doesn't matter. For signaling, you're forced to do targeted LDP sessions. As in any case, you should use CCC, Circuit Cross Connect, the different flavor of CCC encapsulation, to transport similar interfaces, and you also got the possibility of transporting IP datagrams between interfaces which are not the same. And in this case, again, the layer 2 header is going to be rebuilt at the remote side, and this is what TCC encapsulation does. Okay, and again, you don't have any more VRF, no concept of VRF, and you're just gonna exchange inner labels tied to circuit IDs. And this is the idea. I got here basically two pseudo wires, one which is going from site 1 to site 4, and another pseudo wire which is going from site 2 to site 3. So what is going to happen is every P will advertise a label, an inner label, and a circuit ID. Circuit ID needs to match on both sides. So when the remote PE on the remote side receives a label for, let's say, circuit ID 1, and its own circuit ID 1 is tied to site 4, he will know that whenever, if you want, anytime a frame is coming in from site 4, needs to be encapsulated with an inner label, which is the one advertised by the remote PE, and then it's going to be shipped down a transport LSP that brings me to that remote PE. And it's as simple as that. It's a very simple technology and works very well. And this is the detail of the actual label as it has been advertised by the remote PEs. So together with the label mapping itself, you also got the C bit that tells you if you want to use control word for forwarding for encapsulation, the encapsulation type, whether it is ATM or Ethernet or anything else. Then you got the group ID, which is used, it's not used at the moment on Juno OS, but it's supposed to be used if you wanted to withdraw multiple label mappings after an interface failure to achieve faster, if you want, failover. You will see similar feature later on for EVPN. And then you got also interface parameters like MTU. So let's have a look at the configuration. So what do we need? Basically we need to have a mesh of LSPs bidirectional from A to B, from B to A, between all PEs. Okay. Then on top of this, you need to enable LDP on your loopback interfaces. Regardless whether you use it in your core, you need at least to enable it under your loopback interfaces. That is because the loopback interface is where the targeted session from the remote PE is going to terminate. So it's going to be a session between loopback addresses in a way, or starting from a loopback address. Okay. Then you need to have in your backbone, you need to have full mesh of transport LSPs. Sorry, just a second. It's shutting down the mobile phone. Okay. Typically, you set up pseudo wires within the same IGP domain. So you don't need BGP. You don't need a SBP, but very often you need a common IGP. From the point of view of the C device, the C sees just a bunch of circuits. So it doesn't need to be absolutely anything. It needs to do absolutely anything special. It's just the user of our service. And on the P router instead, we will need to define a new layer 2 circuit with a unique circuit ID, or better still, circuit ID needs to be unique only when going to the same remote PE. You just need to specify who your terminating PE is gonna be, so where will the circuit end up, and then which virtual circuit ID to assign to this circuit, and which interface, logical interface, to bind locally to the circuit. And of course, you need also to configure your interfaces with encapsulation typically CCC. And this is a simple topology. In this case, again, on the remote sites, on the Cs, we are going to run OSPF, but that doesn't matter, can be anything. We are just going to run OSPF to see if we can establish an adjacency across our layer 2 circuits. Okay. Then on R1, we will enable LDP, define the layer 2 circuit, and then we will need to build a transport infrastructure. So we can do this with LDP, as in this example, or we could even use RSVP. And this is the configuration on one of the PE, on R1, one of the PEs, from the point of view of the circuit itself. So what do I say here? I say that any frame coming from interface GG 104.5.1.12 is gonna be sent to neighbor 192.168.1.3 with a label for virtual circuit ID 4. That neighbor will then decapsulate it and send it down the interface from its side. And from LDP point of view, we need to enable LDP on our loopback for our targeted session, and then since we are using LDP also for our transport LSP, we will need to enable it on your core phasing interface. In this case, only one. Last thing that we need to do on the PC link, on the P side, we need to enable encapsulation, the correct encapsulation, VLAN CCC in this case. We want to do CCC on a per VLAN basis, so not clear interface, but just one sub-interface. And on the C, we are just users of the service, so we just define an IP interface with VLAN tag 512, that's it, but no special configuration. Those frames are going to be transported via our layer 2 circuits. So as you've seen, the configuration is actually really simple. The main problem with it, scalability is not that great. Let me go back a second. Scalability is not that great because if you got 100 circuits or 200 or 300 circuits, all of them needs to be explicitly configured with individually assigned circuit ID and so on. Moreover, if you got any-to-any VPN and you bring up a new P, all Ps will need to be changed to provision the new circuit in a way, going to the new P. We will see later on that this can be mitigated somehow with VPLS, with auto discovery. And VPLS, it is going to be really crucial. Another thing to say is you can use different types of protection features for layer 2 circuits. This is an example, and this is just an example, meaning there are several of those features. In this example, I am actually doing local interface switching, so traffic coming from site 1 is going to go not via MPLS, via just a normal circuit to PE2. However, I want to make sure if something happens on this circuit and the connection between PE1 and PE2 goes down, I want to be able to use a layer 2 circuit via an MPLS backbone. In this case, only one router, PE3. So what I will need to do, I will need here on PE1 to configure a local interface switching to say that every frame coming from site 1 needs to be sent out of this interface on this working path, as it is. But then, if for some reasons this interface goes down, I want to start to use a layer 2 circuit going via PE3, and then we will need to configure layer 2 circuits. Again, this is just an example. For more information, you can refer to the Juniper website. But let's have a look anyway. One last thing. In order to detect failure, I need a way of checking that I can actually go from P1 to P2, especially if you got switches in the path. You will need to enable Ethernet to IM. So this is the idea. IGP is single area SPF. IGP should be actually only in this area here. It's not going to be between P1 and P2 on the working path. It's going to be on P3. And this is the configuration. What I'm saying is I want to do local interface switching, and this interface here needs to be protected, and I want to protect it via layer 2 circuit with virtual circuit IT2. And I also put this community here, and this community is going to be used then later on can be used to select next stop. This is not a BGP community, it's an LDP community, just a tag that I'm gonna associate in a way to traffic for layer 2 circuit that I want to be protected. I will then match LSPs with a special regular expression for name and install those protected LSPs, protection LSPs, only for next stops which are tagged routes, or let's say next stops, which are tagged with this community. So this is the interface. This is the outgoing interface.